Hello everyone. Today we'll talk about section 7.6, probability. Okay, so before we talk about how to calculate or what probability is, we want to discuss some terminology first. So first one is sample space. Sample space is the set of all possible outcomes in an probability experiment. So for example, if you toss one coin, then the outcomes will be either a head or a tail. Okay, if you roll a die, then the possible outcome will be one of these six numbers. So the possible outcomes are these six numbers. And if you toss it once, then you get one of those six numbers. And these are called the sample space. Now, looking at the first example, the question is, what is the sample space of tossing a coin twice? Okay. So if I toss the coin the first time, what would I get? I'll get either a head or a tail. Now if I toss it the second time, again, I'll get either a head or a tail. So now, how many combinations would I have? Well, I could toss, now my sample space, let me write it down first. Sample space. Then what combinations would I have? Well, if I toss head first, and second time I could toss a head or I could toss a tail, right? Now, if I toss a tail first at the first time, then in the second time I toss the coins, it could be a head or it could be a tail. So we have four combinations, and these four are our sample space. And another way to write sample space is that S, we use S to represent sample space, and then big bracket, head, 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 tail, tail, head, tail, tail. Okay, so this is our sample space. All right, next we're talking about the tree diagrams. A tree diagram is a method of listing sample space in a systematic way. So for example, the first one, this tree diagram can be used to represent two coins or a coin tossed twice. So if the first time or the first coin, there are two, for the first coin or for the first time, you can have two possibilities, a head or a tail. Now this is the second coin or the second time. If the first time is a head, then the second time could be a head or a tail. If the first time was a tail, then the second time you can still have a head or a tail. So in the end, these are your sample space. Okay. Now, the second example here is three children. So three children were born in a family, and their sex is a female or a male. So B stands for boys and G stands for girls. So for the first child, it could be a boy or a girl. So that's the first one. And the second one it could be a boy or a girl. And then the last one, the third one, again, could be a boy or a girl. So there are 8 combinations. They can have 3 boys, 2 boys and a girl, so 2 brothers and a little sister, a boy, a girl, and a boy. So this is the oldest boy, second oldest is a girl, and then the youngest is the boy. And of these, is the sample space. Okay, the next one, probability. Okay, so probability is the chance of event occurring. Okay, so how do we calculate probability? The probability of an event E is calculated like this. Okay, so it's all of the outcome of a sample space, so the number of outcomes on the denominator, and then on the numerator, it's the number of outcomes of that event. So let's say, for example, example number 2 here, what is the probability of getting 2 heads when 2 coins are tossed? So we know the sample space from example 1, let me copy that down, is HH, HT, TH, and TT. When do you have 2 heads? Well, right here. Okay, so how many times can 2 heads appear? Probability of 2 heads. Well, it can only appear once because that's the only one that when it appears, right? Other ones were heads, tail, tail, head, and tail, tail. So it can only appear once. Now, the denominator should be the size of your sample space. So how many items or how many terms there are in your sample space? Well, we know in our sample space we have 4 outcomes. So it's 1 over 4. So the probability of 2 heads is a quarter, or you can say it's 0.25. Okay. Example number 3. What is the probability of selecting a red, not read? Let me change the color. Red jack from a deck of cards. Well, first of all, how many cards are there in a deck? Number of cards in a deck of cards. How many cards are there in a deck? This will be our sample space. Okay, and we know that there are, so the number of card is 52. We know in a deck of card there are 52 of them. Okay, now the question is, what's the probability that you can select a red jack randomly from this deck? Well, how many red jack do we have? We have 2 red jack. One is the heart, and the other one is diamond, right? So the possibility of drawing 2 cards from from 50 cards in total will be red J will be 2 out of 52, because 2 is the number of cards there are in the deck, and 52 is the total number of cards you have. So if you simplify it, it's 1 over 26. Okay, so this formula here is the formula you use to calculate the probability. All right, next example. What is the probability of rolling a sum of 9 with 2 dice? Well, if I have 2 dice, then let's draw a tree diagram. If my first die, first die or die 1, die number 1. If my first die is let's say a 1, then my second die, there will be 6 possibilities. 1, 2, 3, 4, 5, 6. Right? Now, if my first die is a 2, then my second die number 2, still they will have 6 possibilities. And then if the first die is 3, still 6 probabilities, 6 possibilities, and then 4. And then we can have 5 and 6. So this is our tree diagram. And the question is, what is the probability of rolling a sum of 9? Well, if you have the first one as 1, then 1 plus 1 is 2. Let me just write down the sample space. Sum, sum, 1 plus 1 is 2. 1 plus 2 is 3, and then 4, 5, 6, 7. That's from the first part. And then from the second part, 2 plus 1 is 3, 4, 5, 6, 7, 8. And then we can have the third one, 4, 5, 6, 7, 8, 9. And then fourth one will be 5, 6, 7, 8, 9, 10. And then the fifth one, 6, 7, 8, 9, 10, 11. And the last one, 7, 8, 9, 10, 11, and 12. So this is our sample space. Okay, all of these numbers is our sample space. How many are there? Well, each one has 6. So, right, each of these branch has 6 outcomes, and we have 6 branches. So in total, 6 times 6, we have the number of our sample space is 36. We have 36 numbers in total over here. Now, how many of them has a sum of 9? Well, now let's just look for 9s here. It's 1, 2, 3, and 4. Oops. So I have 4 9s in total. Now, we know that the number of 9s is 4, and the number of the sample space is 36. So if you want to find the probability of rolling a sum of 9, then that is going to equal to number of 9s divided by the number of sample space, which is 4 divided by 36, and that is 1/9. Okay, so that's it for the examples. And on the last page here, this is from page 291 on your workbook, and it has a few probability rules. There are 5 in total, and let's go over each of them. So the first rule says that the probability for any event, will be between 0 and 1. Okay? So probability of an event is between 0 and 1. It's never going to be less than 0, like a negative, and it's gonna be always less or equal to 1. It's never going to be more than 1. Okay? So probability will be between 0% and 100% inclusive. A second one, if an event is not happening, If an event is not happening, then you know the chance that the event is happening will be 0. So the probability is 0 if it's not going to happen. Well, so example here says if you're rolling a die that are six-sided, and in order to have an outcome of 8, what's the probability? Well, 8 is not a phase of your die, so getting an 8, the chance is 0, right? Because you're never gonna get an 8. The chance of getting 8 is 0, and the sample space is 6. So 0 divided by 6 is still 0. Well, and if an event is certain, then the probability is 1. Okay, so for example, let me just highlight this. So for example, if you are rolling a die, one single one, and you want to have an outcome that's between 1 and 6, well, we know the numbers of your die is 1, 2, 3, 4, 5, 6. If you want to get an outcome that's between 1 and 6, then it's going to be 100%. Because doesn't matter which number you get, it's going to be 6. So the number of event is 6. The number of sample space is still 6. 6 divided by 6 is 1. Okay, rule 4. If the probability of an event is happening is P of event, then the probability of the event that will not happen is 1 minus PE. And that is represented by a bar on top of the E. This is saying that E is not happening. Let me label that. E with a bar means not E, or E is not happening. Okay, oh, it has it here. So for example, if the probability of that it will ring is 3/7, then the probability of that it will not ring will be 1 minus 3/7, which is 4/7. And if you look at this example, if the probability of at least one girl, if you're looking for the probability of at least one girl, then you can just use 1 minus probability of no girls. Okay? At least one means it can be one or more. So the only thing that's excluded is when there's no girls. So you use 1 minus probability of no girls will be the probability of at least one girl. Okay, last one. The sum of the probability of all outcomes in a sample space is always gonna be 100% or 1. And there's a simple example. So the sample space of flipping a coin is either a head or a tail. So the probability of getting a head is a half, 1/2. 1 head over an outcome of 2, 1/2. And probability of getting a tail is 1/2 as well. So 1 tail out of 2 outcomes in total. If you add them up, it's going to equal to 1. And it has to equal to 1. Okay, if when you're summing up the probabilities of all outcomes in a sample space, if that is not equal to 1, then it means you've done something wrong and you have to double check your solution. Okay, so your homework for today are the questions listed up here. Please try them and let me know if you have any questions.